In this video, we will see how to model interaction between two independent variables. So let's say that our initial model is that our y I hat is a function of two independent variables, x1 and x2, and the interaction of the two. So x1 times x2. So this may be the case where not only do these variables matter by themselves, but they also engage or interact with each other, and then their joint effect is then felt on our outcome variable or dependent variable y. So for example, let's say that we have a data from a company, and that company has collected data on their revenue or sales. Then they have the data on the price of their products. What is the link between their product price and their sales? Then they have also data on how much money they spend on advertising. So far, what we have seen is that the equation would simply be that our sales are a function of just an intercept plus B1, our price, plus B2, the money spent on advertising. However, in this case, let's say that we have reason to believe that price and advertisement interact with each other as well. So then the model actually becomes our sales are a function of our price plus the money we spent on advertisement and an interaction of these two variables, price versus advertisement. Now, one quick way to interpret the results of this model is to see what is the effect on my price change or a dollar change on the price of my product on my sales. So in the simple or the multiple regression model, we would just look at B1, which tells us the effect of a dollar change in price on our sales. However, now notice that price not only appears here by itself, but it also appears interacting with advertisement. So if we kind of use the idea of the derivative of sales with respect to price as capturing the rate of change of sales with respect to a change in price, we can simply write del sales, del price, and is first the slope coefficient on the price variable, and then price also appears in an interactive way. So we can show using calculus that this is B3 times advertisement. So what is interesting here is that the effect of a change in price on our change in sales depends not just on price itself, but also at what level of ad spending are we talking at. So maybe at the average ad spending, we would have a different effect of a dollar change in price on our revenue change. At the first quartile, it could be a different effect. At the third quartile, it could be a different effect. So here, we need to also identify the value of advertisement that we are referring to in studying the true effect of a change in price on our unit change in sales. And let's see how we can implement this in JUMP. This is a data set where our dependent variable is our sales or our revenue, and the two independent variables are price and ad spending. And again, we are modeling interactions between price and ad spending, as well as the effect of these two independently on our sales. So the first thing we need to create is create a new variable, which will be a product of our price and advertisement expenditure. And to do that, we can kind of activate this column, right-click, create formula, and then here we'll just say price times our ad spending. Click OK. And let's just call this price underscore ad, keeping the convention that we've been using, AdWord spending. So this is our interaction effect of price and our ad spending. Then once we've done that, we will just follow the same process to run a regression model. We'll click on Analyze, click Fit Model. we move our sales as our Y variable, and then we'll move price, ad spending, and price times advertisement as our X variables. And then we run this. That if we look at our results, what we find is that the equation is given by price, the coefficient is 175, ad spending, the coefficient is 19.68, and then price times ad spending, the coefficient is minus 6.08. So this tells us that on the face of it, the higher we charge for our product, our sales or revenue is increasing. If we spend more money in our ad spending, our sales are increasing, but the interaction kind of is negative. So also notice that all three variables are statistically significant at 5% level of significance. So if we translate this into our estimating equation, what we get is that our sales are a function of our intercept, price, ad spending, and then interaction of price times ad spend. So we're going to study the effect of my change in price on how my sales change. The functional form of this equation would be delta sales over delta price. Taking out the partial derivative, we will get it as 175 minus 6.08 times advertisement spending. So if I plug in the value of 100, which is $100,000 ad spending, we will get a different answer. And then if we plug in, let's say $200,000, which is in thousands of units, 200, we'll get a different answer. So as our ad spending is changing, the effect of a change in price on our sales is changing as well. And this is captured by this interaction term between price and ad spending.